All right, so let's, this is the fourth time we've done, I didn't even write what the section was. It's equations of lines, okay? So that's what we're doing right here. So we've done a lot of stuff with equations of lines. The last thing we've done was graphing things. I'm going to do, I tell you what, I'm going to review briefly one little thing, and then I'm going to do something that we really haven't seen yet. But it has a lot to do with what we've done before. All right, so let's do a quick little review over this. It's been a little while since we talked about this. We had Thanksgiving break, and plus this was kind of early on in this lesson, and we've taken a long time on this lesson. But this lesson is that important, okay? I really think that this is that important because you're going to be doing this stuff in Algebra 2, all right? You're going to be doing it pretty much right away. And your Algebra 2 teacher is going to expect you to know how to graph lines and about equations of a line and about parallel lines and perpendicular lines and all that. They're going to expect you to know that when you walk in the door, okay? So that's why I'm really harping on it right now. So we're going to talk about parallel lines, and what's the other one? I said it earlier, just a second ago. It starts with a P. P-E. Perpendicular. Okay. So do we know what that means? Perpendicular lines. Okay. Well, let's talk about it. So if I have parallel lines, just tell me anything. Go ahead, Zion. What do you know about parallel lines? You said it earlier. You said it a second ago, but you kind of... They don't touch. They'll never touch each other, okay? So parallel lines never intersect, okay? Touch is kind of a non-geometry word, but I get what you're saying. But they don't intersect each other, okay? Everybody got that? All right, so parallel lines will never intersect. So I could take these and like change the angle of it. Are they going to intersect? Nope, doesn't matter how I change the thing. Okay, those will never intersect each other. So they're what? Parallel lines. Now, there's something that we learned in this section about parallel lines and about their slopes. Look at the slope, or look at how it's slanted. See how this one's slanted and this one's slanted? Is one any steeper than the other? If I was going to walk up this mountain, is that any steeper of a climb than that is? It's the same steepness, isn't it? Same exact steepness. So they have the same what? The same slope. Okay? They have the same slope. All right? Or, here's what we're going to do. I'm going to go M. What is that? No, we haven't turned in the homework. In fact, I didn't even go over one, did I? Did I do one? I just did one. Yeah, I did that one. Yeah. We'll turn the homework in before we leave. I don't want to do it right now because I'm in the middle of teaching. But you're right, I should have collected it. But anyway, let's take a look at this. They have the same slope. So what does the letter M represent in geometry? It's the slope. So I'm going to put M1. What does that mean? The slope of line 1. And this would be line 2. So the slope of line 1 is what compared to the slope of line 2? They're equal, okay? Everybody with me on that? So let's do a little bit more before I talk about perpendicular. This is old stuff, okay? I've taught this before. Whether or not you learned it or not, it's a different story, but I have taught it. Let's do this. Let me give you two equations. So y equals 2/3 x minus 2. There's one equation. Let me give you another one. Y equals 2/3 x plus 3. You see those two equations? What can you tell me about those two lines? I mean, you could graph them, couldn't you? Right? So if I graphed it, I'd put a point at -2 on the y-axis, and then from that point, I would rise 2 and run 3. Yeah? Okay, they're parallel. How do you know, Donnell, that they're parallel to each other? Just by looking at them. They have the same slope. Exactly right. That's exactly what I was looking for. Okay, see that slope is 2/3, and see that slope is 2/3? What does that automatically tell you about those two lines? They're parallel to each other. Everybody see that? All right. So you go up 2, you go over 3, right? So let's say that was my y-intercept. You go up 2, you go over 3. That would be the slant of a 2/3 slope. And the other one would be the same thing, except it just goes, one's higher up, right, and one's lower. See, this one's higher up because it goes through +3 on the y-axis. This one's a little lower because it goes through -2 on the y-axis, but they still have the same slant. You got me on that? Okay, so parallel lines. What do I know about the slopes of parallel lines? They're the same. They're equal to each other. We good? All right. Now, let's jump over to what? Perpendicular lines. Now, let me draw two lines that are perpendicular just so you can kind of visually see what it looks like. Okay? So those two lines are perpendicular. Actually, just looking at them, can you say 100% they're perpendicular? Not yet. What would you have to know if they're perpendicular? Well, that this is a what kind of an angle? A right angle. Very good. Which is how many degrees? 90 degrees. Good. All right. So, are these two lines perpendicular to each other? Yeah. I could actually extend it. It doesn't have to stop right there. I could take it down like that. Okay? Everybody with me on that? So this is a right angle. That little box means it's 90 degrees, and these are perpendicular. Doesn't matter how it's slanted. What about those two lines? Are they still perpendicular? Yeah, absolutely. Because what? There's a 90-degree angle, right? But there's something we learned earlier in this section, not just in the chapter, but in this section, we learned something about lines that are perpendicular, and we learned something about the slopes. Okay? Reciprocal is one of the words. I'm gonna write down two words, and hopefully you'll understand what it means. I'll explain it. The slopes are negative reciprocals. You're like, Mr. Hamrick, I have no idea what that means. But I'm going to show you. All right. Let's say this slope right here, I don't know, up here. Oops, that's not very horizontal. I don't know. Let's say it's kind of like a 1, isn't it? Let's say it's 3/2. All right. So let's say the slope, this is line 1, and this is line 2. So line 1, the slope of line 1, I'm just making that up, okay? I don't know what it is exactly, but I just made it up. Let's say it's 3/2. Everybody with me on that? So the slope of this line is 3/2. If they're perpendicular to each other, I should be able to find the slope of the other line, line 2. It's the negative reciprocal, which negative means it's the opposite sign, okay? It doesn't mean it's always negative. It just means it's the opposite sign, okay? So what's the sign of my number 1 line? Positive or negative? Positive. So what's the sign of my second line going to be? Negative. Now, reciprocal, what does that mean? If it's a fraction, what do I do to get a reciprocal? Just flip it. That's right. So instead of 3/2, it's what? Yeah, just 2/3 and a negative out in front. So if I know the slope of this line right here is 3/2, and I know they're perpendicular, okay? If I know they're perpendicular, then I can find the slope of the other one, which is what? -2/3. You see that? All right, so it's a little bit more involved than the parallel. Parallel is easy, right? If they have the same slope, they're parallel. No big deal. Perpendicular is a little bit, not much, but just a little bit trickier because the slopes are negative reciprocals. So let's do what I did to the parallel down here. So I'm going to tell you what, I'll use those same slopes. So what if I had an equation of a line, like 3/2x minus 1? Then I had another equation, which is y equals -2/3 x plus, 5. Okay? Here's my two equations, my two lines. These are two lines, aren't they? I could graph them if I wanted to, but just looking at them, what can you say is in common? What can you say is the relationship between these two lines? What do they have in common? Well, it's not really in common. I shouldn't say that. What's the relationship between them? Look, what's the slope of this line right here? 3/2. What's the slope of this line? -2/3. What can I say about these two lines? They are the two lines. They're not reciprocals. They're perpendicular. That's right. Okay, so the two lines are perpendicular. All right? We actually learned that before. For some of you guys, you're like, man, I've never seen this in my life. But we have. Look back on it. Everybody with me so far? Okay. Now, keep that in mind. Let's go through it one more time. All right? It's always good to have a little repetition here. So what's true about the slopes of two lines if the lines are parallel to each other? They're the same. They're exactly equal to each other, right? 2/3, 2/3. They're parallel. Come over here. What's true about these two lines? I mean, it's right in front of you. They're perpendicular. Okay, why are they perpendicular? Because the slopes are negative reciprocals of each other. That's right. Okay? What's a negative reciprocal of 4? That's it. It's negative 1/4. Very good. Everybody see that? What's the negative reciprocal of negative 5/7? Positive 7/5. That's right. Okay? Because you take the opposite sign. So this one's negative, so this one's going to be positive, and you flip it, 7/5. You getting the hang of negative reciprocal? Yeah, that's not too hard, is it? Right? You just take the opposite sign and flip it. That's all you do. You change two things. That way, the slopes of these two are going to be perpendicular, right? If this has a slope of negative 5/7 and this has a slope of 7/5, those lines are perpendicular to each other. Okay, enough of that. That was review, believe it or not. What I'm going to do is this. I'm looking at my notes. I don't think I wrote enough stuff. Hold on. Am I referring back to another example? Let me see. Hold on. Give me a second. Okay, I see what we're going to do. Tell you what, let me get the book out. Sorry about that. So 3.5, example 5. Because it seems like I'm missing something in my notes. Oh, okay, I see what they did. I did forget to mark something on my notes. How do I want to do this? Let me think. All right, let's just do it like this. Let me grab that graph right here. Actually, you know what I'm going to do? I will do this. Let's do that. Let's continue with what we were just talking about, then we'll do the brand new stuff. So remember I said earlier, part of today is going to be review for the quiz, even though we're going to review some more tomorrow. So this is going to be the type of problem that's going to be on the quiz. All right, everybody watching? So I'm going to give you 4 points. So write this down because you're going to see this on the quiz. It could be different numbers, okay? Or it could be the same numbers. I don't know. It might be exactly the same. So it'd be a good idea to write it down. If it's not exactly the same numbers, it's going to be very, very close to this. Yeah. All right, I give you 4 points. So what I'm going to ask you to do is I am going to ask you about line AD and line BC. I'm going to ask you to tell me something about those two lines. So what do you think I'm going to ask you? What did we just finish doing? Either the lines are perpendicular or parallel, right? Parallel or perpendicular, okay? So that's what I want you to say. Or it could be neither, right? They may not even be perpendicular or parallel, all right? But I got line AD. So let's write down AD. A is negative 3, 4. D is 0, 3. I was going to draw it on the graph. That was part of my delay on this, but I think I'm just going to do it like this. Now, how in the world, now this is a line, correct? All right, and then BC is another line. So let's do BC. So let's put B right here. I'm just putting next to each other so I know which ones I'm doing. 1, negative 4. So these 2 points make a line, right? If I was to graph those 2 points, I connect them, I got a line. Everybody good with that? These are 2 points. I could connect those two and get a line, right? And then I'd have to decide, are they parallel or are they perpendicular, or is neither one of those things true? So how am I going to do that? How am I going to, without graphing, how am I going to be able to tell if this line, AD, is parallel to this line, BC? Or is it perpendicular? Find the slopes. Exactly right. Evan, is that what you're going to say? All right, we're going to find the slopes. All right, so let's find the slope. Now, we haven't talked about that today, but this is something that we've done. I think we've even had a quiz on this. How do I find the slope of line AD? Do you remember what the little formula was? Yeah, you do minus. What do you minus? That's it. You minus the y's on the top, subtract the y's on the top, and then you subtract the x's on the bottom. That's right. So, yeah, it doesn't matter as long as you do them in the same order. So I could go 3 minus 4 or 4 minus 3. It doesn't matter. What do you want to do? 3 minus 4? Okay, that's fine. So let's go 3 minus 4. Again, this is something that we've talked about before. So that's how you find the slope, 3 minus 4. What do I do with the x's then? Yep, 0 minus negative 3. See what we're doing? We're finding the slopes. Why in the world are we finding the slopes? It doesn't even say in the problem to find the slopes. It just says, tell me whether the lines are perpendicular, parallel, or neither. So why am I finding the slopes? Because I want to compare the slopes. If they're the same, then it's parallel. If they're negative reciprocals of each other, then it's perpendicular. Got it? That's why we're trying to find the slopes. So what is this? 3 minus 4 is what? Negative 1. What's 0 minus negative 3? Minus a negative is plus, so it's a positive 3. So what's the slope of this first line right here? It's negative 1 over 3. Okay? So I'm going to put, oops, don't want that. There we go. So the slope of line AD, see what I did? All right, slope for M, AD, because I'm trying to find the line AD. So that's my one slope. So what am I going to do to this line over here? Find the slope of that. And then compare them. Look at them. If the other slope is negative 1/3, then what are those two lines? They're what? No, if the other one is negative 1/3, then the two lines are, if the other slope comes out to be negative 1/3, then what's true about these two lines? They're parallel to each other. What if they were perpendicular? What would the slope of this be if they were perpendicular? Be 3 over 1, right? Okay? What if this was like 2/3? Then what would you say? Then you'd say neither. Okay? So you got three choices. All right? You got parallel, you got perpendicular, you got neither. Now, if you get on the quiz and just write down parallel, even if that's right, and you didn't show how they're parallel, I'm going to mark it wrong. And in fact, even on the quiz, I said show why they are whatever they are. All right? So you can't just do a 1 in 3 guess. All right? All right, let's do this quick. Here we go. I'm talking too much. So the slope of BC, subtract the y's. Again, it doesn't matter. If you want to go to the second minus the first, that's fine. So negative 4 minus 2. Let's subtract the x's, put it on the bottom. So I got to go in the same order, though. So I got to go 1 minus 3. And what do you get? What's negative 4 minus 2? Add the opposite. What's that? That's negative 6. What's the bottom? 1 minus 3. Add the opposites, not 2. It's what? It's negative 2. So what's negative 6 over negative 2? Positive 3. So the slope of this one was negative 1/3. The slope of this one was a positive 3. So what can we say about those two lines? They are what? They're equal. Equal is never a choice. They're not parallel. Why aren't they parallel? If they were parallel, they would have what? Just answer my question. You're right, but answer my question. If they were parallel, then what would be true about the two slopes? They would be the same. Are they the same? No. What are they? They are what? Negative reciprocals. This is negative 1/3. This is positive 3. Positive 3/1. So what must be true about those two lines? They are what? Perpendicular. And that's your answer right there. Perpendicular. But you got to show how you got it. Right? So that technically is the answer. Because I ask the question, are they parallel, perpendicular, or neither? All right? You got 3 choices. That's your answer, but this is how you got the answer. You have to show me this. Everybody understand that, right? Did you write this down in your notes? A lot of you guys are just sitting there staring at me, which is good. At least you're looking at me, but you should be writing this down. Okay? You absolutely should be writing this down. Everybody good? All right. I hope. That's going to be a quiz question, I promise you. Okay, the numbers could be different, just throwing that out there, but it's the same style of problem. So your answer may not be perpendicular. It may be parallel, or it might be neither. Okay? All right. Let me sign his pass. All right, hurry back because we're doing something new now. Okay, let's do one more. I think we got time. We got 10 minutes, okay? So I think we should be able to do this. I'm just gonna give you the question. It says, write this down. Write the slope-intercept form. I'm going to write the whole thing out so you know exactly what I'm asking for. This is new, all right? It has a lot of things to do with what we've learned already today, all right? But putting it all together, this is a little bit new. So find the slope-intercept form of the equation of the line that passes through actually, this is not even new. I think we've done this already. Through the points, but I'm going to do it anyway. Through the points, here we go. It's 3, 6, and 6, 0. All right, there's a lot of stuff there. Let's take it little bit by little bit and see what we're trying to do. It says, write the slope-intercept. I should have put form. Write the slope-intercept form of the equation of the line that passes through these 2 points. So you know you got a line, right? If I got 3, 6, I could go over 3, up 6, over 6, over 6, up 0. And I could get a line out of it. I want to find the slope-intercept form of the equational line. So what is the slope-intercept form? We talked about this a lot yesterday. What is it? Y what? Speak up, I didn't hear you. Very good. Y equals mx plus b. So that's what we want to do. So how in the world are we going to take these 2 points and make an equation of a line out of it? Well, we've already done the one thing. We did it just a minute ago. What did we just find? We found 2 of them. Found the what? What was the first thing we did on this problem right here? What was the first thing I did between those 2 points? I found the what? Found the slope. So that's what we're going to do right now. Okay? So with these 2 points, I can find the what? The slope. Everybody okay with that? So that's what I'm going to do. Because what do I need? I need a slope and I need a what? Y-intercept. Okay? So that's what I need. So the first thing I'm going to find is the slope. So let's take those 2 points again, 3, 6, and 6, 0. and let's find the slope between them. We've done it twice already today, and we've done it a ton other times, so let's do it again. Subtract the y's from each other and put them on top. 0 minus 6. You could have gone 6 minus 0, all right? But our equation said y2 minus y1, so that's what we'll do. All right, what about the x's? If I went 0 minus 6, what am I going to have to do with the x's? 6 what? Minus 3. 6 minus 3. Let's see what we get. What's 0 minus 6? Negative 6. What's 6 minus 3? 3. Let's reduce it. Okay, always reduce it if it can. What's that going to give you? 3 over 1? 2. 6 divided by 3 is 2. It's negative, correct? It's negative 2. So that's my slope. Everybody with me? Okay, this is the third time we've done slope today. Now, where does that go? That goes where the m is. So I'm going to go y equals what? Negative 2x, what? Plus b. So I got half. I'm halfway done. All right? So I got the slope. Now I got to find what? The y-intercept. Okay? The b, correct. I got to find the b. So now here is the part that might be a little bit tricky, but after you do it a couple times, it's really not that hard at all. Now watch very carefully. Everybody awake? Watching? Because this is going to be on the quiz. In 2 days, you're going to have to do a problem just like this. Everybody hear me, right? Okay, so here's what we're going to do. This x and this y, it represents any point on the line. Do I know any points on my line? Yeah, I know 2 of them. I know that point and what else? I know that point, don't I? So watch what I'm going to do. I can pick either one of the points. It doesn't matter which one I pick. I could pick the 3, 6, or I could pick the 6, 0. Which one would you rather pick? The 3, 6? Okay. I'd probably pick the 6, 0 because 0 kind of makes it a little easier. But let's do the 3, 6. All right, let's do the 3, 6. It doesn't matter which one. So what is the 3? 3 is my x, isn't it? And 6 is the what? The y. So what am I going to put in for this? What am I going to put in for the y? A 6, that's right, because the 6 is y. So I'm going to put a 6 in for that. I already got the negative 2. It's being multiplied by the x. What's the x on this point? It's 3. So what do I put right here? 3 plus what? B. Now, guess what I can solve for? I can solve for b. Once I solve for b, I put it all together, and I'm done. So you really have to find 2 things. Find the slope and find the y-intercept. Okay? So let's just do the math on this. Whoops. Keep clicking this dumb button on this pen. 6 equals, what's that? Negative 6 plus b, right? Add a 6 to both sides. I'm going to do this kind of quick because it's just algebra. That cancels. So what's b equal to? 12. So now I got to put it all together because the question says write the what? The slope-intercept form of the equation of a line. Okay? So how do I write it? Y equals, what was my m? It was at 2? It wasn't 2. Negative 2, all right? You may think I'm being super picky on that, but 2 and negative 2 are completely different numbers, all right? And you can't just say, well, it's just a negative sign, Mr. Hamrick. Well, it's a big difference, all right? Plus what? Plus b, and b is 12, and there you go. That is how you do that problem. That's the slope-intercept form of the equation of a line that passes through this point and this point right here. Okay? If you didn't get it now, if you were half awake, or if you weren't awake at all, and now you're listening to me, you can always watch it on YouTube tonight, all right? And that's going to be one of the problems on the quiz. Let's. All right, this is super easy. This is going to be a question on the quiz as well. This is really, really easy. It should be. At least this one is. This one says, find the slope of each line, all right? So this is a two questions, all right? So the first question says it's parallel to So that should ring a bell. Parallel to y equals negative 5x plus 2. All right. So what are they asking you to do? They're asking you to find the what? Find the slope. Slope of a line that's parallel to this line. Hear what I just said? So I got this line right here. What's the slope of any line that's parallel to this line? Now, it's not going to be y equals. It's just going to be slope. Remember, we're just finding the slope. So the slope equals. So what's the slope of this line right here? It's not 5x. It's just what? What's the slope? What's the m? It's just what? Negative 5. It's negative 5, not 5. It's a negative. I don't know why we don't see that negative in front. It's like the 5th time today. People have just said the number and not the negative. This is a negative 5. So what's the slope of this line right here? It's negative 5. So what's the slope of any line that's parallel to this line? It's going to be negative 5 because any line that's parallel have got to have the same slope. You with me? Okay. So what if I give you this one? What if I said I gave you this line 3x minus 4y equals 2? What if I asked you to find the slope of this one right here? Can I just look at it and say, oh, the slope is 3, or the slope is 2, or the slope is negative 4? Can I just look at it like that? No. What do I have to do to it? I got to set it up, right? Set it up as y equals mx plus b. So what do I have to solve for then? We got to solve for y, right? We did this on that worksheet. We did it earlier today when I did that one problem. So let's do this. Let's solve for y. Subtract a 3x from both sides. That cancels. Bring down the negative 4y. Switch this around. I'm not going to talk about that anymore. We talked about that enough. Divide both sides by negative 4. Divide this by negative 4. That cancels. So y equals, negative over negative is positive. So it's 3/4 x minus, and it really doesn't matter what this is, but it is 1/2. So what's the slope of this line right here? It's 3/4. So what's the slope of a line parallel to this line? 3/4. What's the slope of a line that's perpendicular to this line? Okay, 4 over negative 3, or just put negative 4/3. Okay, that's if it said perpendicular. Okay? All right, we'll do some more review tomorrow. Turn your homework in. I want your homework. And so make sure you don't leave without turning in your homework.